Hey everyone, imagine you're driving your car at a steady speed on a highway and suddenly you pull the accelerator to speed up. What forces are at play under the hood? Is the engine working harder from the start or does friction change everything? Today, we're diving into friction formulas and Solve and IMAT 2025 question that tests exactly this. If you've ever wondered why your car feels that push, stick around. This will blow your mind. Before we jump into the problem, let's quickly review the key formulas for friction. Friction is the force that opposes motion between two surfaces in contact. The basic formula for kinetic friction, the type when things are sliding or moving, is F equals mu n or Fn, where mu coefficient of friction, and n is normal force, or Fn. Usually Fn equal to the weight mg for horizontal surfaces. For static friction, which prevents motion from starting, it's Fs static. F is less than or equal to mu n. It can vary up to that maximum. Many problems like this one, friction is given as a constant force, but remember, it always acts opposite to the direction of motion or intended motion. If you want a deeper dive into the differences between static and kinetic, check out my previous video linked in the description. It's all about the types of friction and real-world examples. Go watch that if you need a refresher. Alright, now let's tackle question 59 from the IMAT 2025 random version. The question reads: a car with a mass of 2,000 kilograms travels in a straight line at a constant speed on a flat road. Okay, its speed is 15 meters per second. At a certain moment, it accelerates with a constant acceleration of 2 meters per second square in the same direction as the velocity. The constant friction force is 2000, and the forces F1 and F2 exerted by the engine in the first and second segment respectively are this. Okay, let's break this down step by step. First, identify the two segments. The first segment is when the car is traveling at constant speed, 15 meters per second. No acceleration means net force is 0. And the second segment, and the second segment starts at t equals 0 with a constant acceleration of 2 meters per second square. Friction force is constant at 2000 and since the car is moving, we assume a kinetic friction opposing the motion. For the first segment, constant speed, net force equals 0. The forces acting horizontally are the engine force F1 forward and friction backward, like this. F1 and friction backward. So F1 minus 2000 equals 0. Therefore, F1 equals 2000 newtons. Now for the second segment, accelerating, net force equals ma. The engine force is F2 and friction is still 2000, backward minus 2000 equals mass 2000 and therefore F2 equals 6000 N. Okay. Now looking at the options, and this matches with E. Easy, right? There you have it. Friction and engine forces demystified with a real exam question. If this helped, like, subscribe, and hit the bell for more physics breakdown. Drop a comment. What's your toughest friction problem? See you in the next video.